My name is Carl Reinhard Kiesler. Today I'll be presenting the HMI Controllable Hydroponics Grow Unit. So an outline. So I'll be going over a brief introduction, my block diagram, the schematic, my flow chart so you understand the programming, the modes of operation for my unit, as well as I have an operational demo, my parts list, and then the conclusion. So traditional gardening and farming, it rains or you have sprinklers to give water to your crops. Some of that water is, some of the nutrients and water is absorbed by the plant, the rest is runoff. Typically, it's about 70% of runoff that you get in that water and the fertilizer waste. Because of this, that costs the farmers and agriculture to spend a lot of money that is wasted because the plants need a certain amount of fertilizer. You have to pump it out there, but then because it's in the ground and because of how soil settles and everything, that is wasted. And hydroponics farming is a way where it doesn't use soil. It's grown in a water medium. And it can save approximately 70% of the water and fertilizer. The system is able to repump it through. It can be continuously reused. You're able to have sensors to check the nutrient level in the water. And from there, you're able to streamline the growing process. So this image is an image of inside of a vertical farm. They were currently growing lettuce. The plants are grown in rows, and underneath is a water trough. And in the water trough, that is where the water is pumped through on the duty cycle. So for my model, I have my DC fans, which are on the two right sides. These simulate an exhaust fan for the unit. I have my room lights in white. That's for if you need to turn on the ability to enter the room, you turn on the room lights and you can see. My grow lights are in blue. They're in the top of the unit. I have a photoresistor that is in the bottom of the unit in the center. This is used to ensure that the lights are working. Because this is an enclosed unit, if I turn on my lights, I want to know that the lights are working without having to open the door and verify that the lights are on. This photoresistor easily does that. If there's light in the room set to a certain level, then the photoresistor will trigger that the lights are on, and then this will let you know that your system is working properly. The Arduino Uno is the brain of the system. That's in the back of the unit. I have a DC motor that I'm using to simulate a water pump. Because the system would have water going through it, I wanted to be able to simulate that. So for the project, the water comes on when the mode is running. The water comes on for 5 seconds and off for 12 seconds. And then I have in the front right here, I have an image of plants. This is to cover up part of the empty space and to show that in here would be plants growing. The HMI is in the bottom of the screen right here. All right. For my block diagram, so the user will be interfacing with the system via the HMI display, which is a touchscreen display. The HMI display sends serial data to the Arduino Uno. Based on the serial data, the blue LEDs for the grow light, the white LED for the room light, the DC fans for the air fan, or the DC motor for the water will turn on. So as the buttons are pressed on the HMI, the program is the serial data is sent to the Arduino, and then the program is written so that if this serial data is present, to turn on either the LED to turn on, or the fans. The temperature and humidity sensor, I use the DHT11. That data is sent to the Arduino Uno, and based on the temperature, after it's converted to Fahrenheit, once it goes above 75 degrees, the fans in the unit will turn on. If it's below 75, the fans will be off. Those numbers can be changed for in actual use. For my schematic, so a PC is required to connect USB to the HMI and for the Arduino so that it can communicate with the serial communications. It's also necessary to use the transmit and receive on the Arduino Uno. That's pin 1 and 2. That's communicating to the HMI. So the serial data is continuously going between the Arduino Uno and the HMI. As that's going, pin 2 goes to the room lights, pin 3 goes to my grow lights, pin 4 goes to my fans, and pin 5 goes to my motors. So that wasn't too complicated. The internal at pin 12 for the DHT11, that's read into the Uno, and my photo cell reads into analog 0 on the Arduino Uno. So for my flow chart, so the user will be required to select a mode. They will then determine whether they want the harvest and plant mode, which is used just for harvesting and planting. The system wouldn't be in this mode for much longer than 3 days. This is just a sort of like a layup position where haven't fully planted, but you want to be able to go in there. So you'd want to be able to turn on the room lights, and you want to be able to turn on the AC fan. So that's all you're listed with there. The other mode is the grow mode. In the grow mode, the user will be presented with 3 different modes to decide which cycle they want to run. The cycles can be changed so that it can be a longer day-night cycle, or it can be 30 cycles long, or an 18-hour day. All that can be changed easily within the program. Once the cycle is completed, it will update a status bar on the HMI display, and this will let you know that the cycle is completed. The final mode is the maintenance. So in the maintenance mode, you'd want to be able to turn on and off the grow lights. You'd want to be able to turn on and off your fan. You'd want to be able to turn on and off your water recirculation, and you'd want to be able to turn on and off the room lights. The maintenance mode and the harvest plant mode are the 2 manual modes that the user would have, but would be necessary for an industrial application for farming, because you need some structure, you need some rigidity where you can say, go in the harvest plant mode, turn on the fan, or go to the grow mode, go to use mode 2. There needs to be standardized procedures, and so having these modes was a necessity. So for the modes of operation, so these are screen captures of the HMI display. In the top left will be temperature and humidity. And this label here will read if the lights are on or off. So this is the first screen that the user will be presented with when the system is turned on. In the bottom in green is the plant harvest button. Second is the grow button. And the third is the maintenance button. So if we go to plant harvest mode and we click that button, you'll be presented with this window. You'll be able to turn on your room lights and you'll be able to turn on your fan. You'll also have an output right here that lets you know if the lights are on or off. This mode is the actual grow mode. So when the user sees this, at first it will say, please select a mode at the top. Once a mode is selected, this text will be replaced with what mode it is, and it'll say running. So for instance, it would say mode 1 running. And then once it is completed, it would say mode 1 completed. Here we'll say if the lights are on or off again. And here's a readout to let you know that the fan will be on above 75 degrees Fahrenheit. You're able to turn on your room lights independent of the mode that's running. And the status bar will update as the mode is running. So you select either mode 1, mode 2, or mode 3. More modes could be added as need is there for them. But for demo purposes, 3 modes were added. The final window is the maintenance mode. So when you go to the maintenance mode, you'll be able to turn on your room light, you'll be able to turn on your grow light, you'll be able to turn on your fan, and you'll be able to turn on your water pump. At the bottom of all of those 3 screens, as well as a home button, when this home button is selected, it will take you back to the home page. So for my wiring, as I mentioned earlier, the Arduino Uno is housed in the back of the system. My wires run through the MDF board and to power my components. So here's a video demo. Are you able to hear that? All right. So that was a quick demo of how it would work. So these are actual photos that are within a crop box. So Vertical Crop Consultants is a company out of North Carolina. I had been in contact with them previously during my time when I lived in Alabama for vertical farming. I was interested in getting some of their units. Since 2016 to now, they have been sending these units out to various companies, various places, and they've been purchasing them. So now they have this research that has actually been done in practice, and they have something to show for it. So I reached out to them to ask if I could use them as an example of what is being done currently. So this is the inside of one of the units. So as you can see, the plants are grown 5 high. Here a user is walking through the units with the UV lights on. And then on the left are lettuce that is soon to be harvested and sent out. Here's another photo showing the layout inside of these units. By growing vertically, you're able to increase the amount of produce that is grown for that land footprint. Inside of one of these containers, they're able to produce an acre's worth of lettuce, the equivalent, in about 35 days. That is much year-round temperatures, as long as you're able to, there's a heat pump on them, there's an AC, you're able to keep it temperature regulated, you can grow. For my parts list that were required, it was necessary to purchase the 5-inch HMI display, the Raspberry Pi, the fan motors, those were able to be sourced from equipment that was here. The Arduino Uno was required to purchase, and the MDF board was used to assemble the frame for the model. 10K resistors were used for wiring, and white LEDs and blue LEDs were used for the simulating the grow lights. So applications where this could be used and for future work. So this could be used in space. This could be used in harsh environments. This could be used in areas that are not hospitable for farming. One of the, and the automation makes it so that agriculture is not the primary focus, but it can still be a focus. If we have astronauts in space and they're doing a mission, it might be necessary for the agriculture to grow, but whatever mission it is or whatever satellite they're repairing is much more important to the company. And so agriculture, by adding in this control system, it enables these people to press the button and say, all right, if I press grow mode 1 in 35 days or in 40 days or however long, I'll have produce that is able to be harvested. And with the feedback sensors, it is possible to know that your system is running. Currently with the units, it's necessary to walk through the units and make sure that there wasn't a water leak or that it wasn't on fire. But you could use a flame sensor, you could use a flooding sensor, and it could be updated on the HMI. There could be an alarm added in. The room for future work is there. This was a similar idea to a smart home. If you go on vacation, you want your lights to come on at certain times so that you don't get robbed. Why can't I make my crops grow for a certain time and then harvest them in 35 days? Um, by controlling the day and night cycle, you also have a consistent flavor and a consistent crop yield. You won't have a problem of some of the plants getting too much sun or not enough sun. It's streamlined, and it's bringing industry into agriculture. The gentleman in the center of the photo is the head chef at the Ritz-Carlton in New York, and he has a crop box unit, and he produces microgreens and salad in his restaurant. It's agriculture needs to have its industrial revolution, and by having a control system that can control the day-night cycle and make all these sensors and equipment feed out, I believe agriculture can have that. So I can give if anyone, so in my references, Vertical Crop Consultants was a huge help in their information that they gave, and as well as Stone, who is the company for the HMI display that I used. But that concludes our presentation. If there's anything else you'd like to see on the model, I can show that. But as far as what I have prepared.
Okay. Thank you, Carol. Thank you very much. I think that video is clear, presented for your operation circuit. That means fine. Yes, the project really support our life needed, because, you know, especially for harsh weather in certain environment, that means we need. So similar for this projects to control growing of the herbs or the plants. That's fine. Thank you very much. Now the floor is open for questions. If anyone has questions, please.
Yes, sir.
I have one. First off, Carl, good job. Great presentation, great project. You mentioned that you can be on vacation and leave your hydroponics on, growing or whatever. In case of power loss, does the mode revert to the last mode that it was running and it continue running that mode, or does it just go back to default where you have to input, you know, a mode again and everything like that?
So currently it stops. If it loses power, it'll just stop, turn everything off. That would be a good addition to, though, to have it save to save that progress, because it does update the status bar, so it is aware. So that would be an addition to the code. That'd be a nice quality of life.
Right. Even a little flicker in power might set you back to the default, which is off.
Right.
Same thing with my smart parking. It would default to 0 again, and the parking lot is full. So that kind of, I got to think about that as well.
Right. No, thank you for that.
Hey, great job, Carl.
Thanks, Alex.
Cool. Good job, Carl.
Thank you.
Hey, Carl, I know you struggled and talked a little bit during your project, and I know you were, last week, we were wondering if this thing was gonna come to a fruition, and you spent all weekend working on it, and I just want to applaud you on that effort, because you put some hours in on this thing, so congratulations, man, great job.
Thank you. Yes, yeah, I'm glad. I'm glad it finally it started behaving the way I had dreamed in week 1. That was my battle was, you know, it. Why isn't it? It's worked up here, but it didn't want to work down there. But I think it was a great learning experience for sure. So thank you for all your help.
This where the engineering meaning. For example, if there is problem, that means you need to see where the resources, how to conduct the right resources to find the solution. This one of the also the goal from the senior project. Practice. I have problem. I need to look where I can find the for the solution. You can. I see you contact the company. You contact different. That means fine. This is how to build your knowledge. Excellent.
Yes, sir.
Any another question?
Great job.